Hello everyone. In this video we're going to be solving a homemade polynomial system. We have x squared plus y squared plus z squared equals 5, x cubed plus y cubed plus z cubed equals 9, and x to the 5th power plus y to the 5th power plus z to the 5th power equals 33. Now let's go ahead and set some variables for the sum and the product here, and then we're going to start solving this system. So first of all, let me set x plus y plus z as s and the product as p. Now I'm going to start by multiplying these two equations because that's going to give me some information about the sum of fifth powers, unless you want to go with the sum of fifth powers, which will be quite complicated. So I'm going to go ahead and multiply x cubed plus y cubed plus z cubed by x squared plus y squared plus z squared, and that's going to give me 45, right? Let's go ahead and distribute, but one thing to notice, when we distribute, we're going to be getting terms like x to the 5th, y to the 5th, and z to the 5th, but also something like x cubed times y squared, y cubed times z squared, so on and so forth. So we can kind of break it down into basically two pieces like this. We can write it as x to the 5th plus y to the 5th plus z to the 5th, and now we're going to get x cubed y squared, x cubed z squared, and then y cubed x squared, y cubed z squared, and then z cubed x squared, and z cubed y squared. All right. Notice that in those terms, we are multiplying a third power by the second power. So we do know x to the 5th plus y to the 5th plus z to the 5th is equal to 33. That means the rest of this expression is going to equal 12. Great, let's go ahead and organize that a little bit. And don't forget, we have two expressions, the sum and the product. So I'm going to put the x cubed y squared with y cubed x squared. So these two are going to pair up nicely. And where's my y cubed x squared? Right here. So those two, we can basically take out x squared y squared. And then we'll get x plus y. And we can pretty much do it for all the pairs. So I can do x squared z squared with x plus z. And then y squared z squared with y plus z. And this is supposed to equal 12, right? Now, in this case, we have the x plus y. We don't have the x plus y plus z, but we can definitely use the sum, the s, to write x plus y in terms of something. And this is what it looks like. So I'm going to replace x plus y with s minus z, since x plus y plus z is equal to s. And if you're trying to isolate x plus y, you can basically do it by subtracting z from both sides. And we can definitely do this for all of these. This can be written as s minus y, and this can be written as s minus x. So this gives us something nice. Let's go ahead and put those together. I get x squared y squared s plus x squared z squared s plus y squared z squared s. I want to put all the s terms together. And then the rest is going to have a minus sign. Notice that the rest is going to look like this: x squared y squared z minus x squared z squared y. So we're kind of like distributing this way, right? Or yeah, it's upon the y. And then let's see, yeah. So let me see, x squared y squared, okay, x squared y squared z, x squared y squared, x squared z squared y, and y squared z squared x. Okay, great. So it's only going to bring 3 terms. Now, the first 3 terms here, we can take out an s, and that's going to give us x squared y squared, x squared z squared plus y squared z squared. And then the rest can be factored out like x, y, z. And then since I take out a negative, this should be x plus y plus z, and that equals 12. So it's nice that our product and sum appears here, so I can definitely replace them. But what about the x squared y squared thing, right? So I kind of have to find something for that. So let's go ahead and explore the following. In order to get this sum, I would need to square xy plus xz plus yz. Let's go ahead and square that. When we do, we get x squared y squared plus x squared z squared plus y squared z squared, but we also get the 2ab, 2ac, and 2bc. All right, so that gives us 2x squared yz plus 2, if you multiply these two, 2y squared xz, and then 2z squared xy. Now here we can basically organize this. So let me go ahead and rewrite this. And now this is what I'm looking for. You can also call it something if you want, but I'm not going to do that right now. I'm just going to rewrite it. And then the rest can be factored. So we can take out a 2xyz and we get x plus y plus z. So our sum and product appear one more time. So that's nice. We can basically do those replacements and then kind of put it all together. But here's the thing. I would need, from here, I would basically also need to find out xy plus xz plus yz. So let's go ahead and let's go ahead and square x plus y plus z now. That gives us x squared plus y squared plus z squared plus 2 times the quantity xy plus xz plus yz. So maybe I should do this first, but anyways, in this case, we're going to find, oh, not that, I want this. Okay, so I know that the sum is s, and the sum of the squares is one of the equations given, right? That is equal to 5. So we have a numerical value for this, which is good. So from here, we can find this in terms of s. If you subtract 5 and divide by 2, you get the following. xy plus xz plus yz becomes s squared minus 5 divided by 2. So that's an important finding. We're going to go ahead and use this, obviously, right, in different places. For example, in this one, we want to use it, right? And then once we find an expression for x squared y squared plus x squared z squared plus y squared z squared, then we can go ahead and plug it in here, right? All right, cool. Well, actually not there, but this one I meant. Okay, here we go. Okay, we have a lot of equations, so that's a little confusing here. So bear with me. So let's go ahead and plug it in here. So on the left-hand side here, I get s squared minus 5 over 2 quantity squared equals x squared y squared plus x squared z squared plus y squared z squared. Plus, this is p and this is s, so that would be plus 2ps. Awesome. So from here, I can basically isolate x squared y squared plus x squared z squared plus y squared z squared. Let's go ahead and do that first. X squared y squared plus x squared z squared plus y squared z squared can be written as s squared minus 5 over 2 quantity squared minus 2ps. So this is also a good thing, something that I will be using in my equations, right? Okay, awesome. So now let's go ahead and go back to where we got the 12, right? 12 is obtained by s times blah, 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 right? So let's go ahead and plug it in there. S times, now notice that s is being multiplied by x squared, y squared, x squared, z squared, and y squared, z squared, which I found an expression for. So let's go ahead and multiply s by that, which is s squared minus 5 over 2 squared minus 2ps. That, and then we're going to multiply, it's equal to 12. So it's this one. Minus xyz, which is p, times x plus y plus z, which is s. So this is s and this is p, right? Let's go ahead and write. So that's going to be minus ps. Okay. PlayStation. No, it's ps. P times s. And this is equal to 12. Awesome. I get a much nicer expression now. I don't have any x, y, z's. I have only s and p, which is good. But this is two variables, so I do need another equation. And for that, I'm going to use the sum of cubes. Now, remember, we're given x cubed plus y cubed plus z cubed, so why not use that? So, remember, we have an identity for that, right? For the sum of the cubes. And that was x cubed plus y cubed plus z cubed minus 3xyz. Can be written as, can be factored as, and I want to kind of put this a little bit more to the left. All right. This can be written as x plus y plus z multiplied by x squared plus y squared plus z squared minus xy minus xz minus yz. This also can be used to prove that if x plus y plus z is equal to 0, then x cubed plus y cubed plus z cubed is equal to 3xyz, which is something that is often used in math competitions. Okay, great. So we have a numerical value for the sum of cubes, which is 9. So this is 9. 9 minus 3p, which is the product, equals s. And now remember, for x squared plus y squared plus z squared, I have 5 minus, and also for xy minus xz minus yz, I should have an expression which is this one, s squared minus 5 over 2. Awesome. Now I know this looks kind of confusing, but what we have here is a system, right? We have a system in two variables. It's not linear or quadratic. It is kind of quintic, but that's okay. We'll take care of that. So one idea here would be to isolate p, and you can definitely do that from the second equation. Notice that here, isolating p is not too hard. And to spare you the trouble, I'm just going to give you what p is in terms of s, and you can definitely check that. P can be written as s cubed minus 15s plus 18 all over 6 from this equation right here. All right. So now I got an expression for p. I can definitely go ahead and plug in here and here. And then if you do, you're going to get something that looks like this. But again, I'm going to skip some of the steps because they're really time consuming and I don't think you will have the patience for that. But anyways, at any rate, I'll spare you the trouble. But let me just show you what the setup looks like so you can kind of appreciate the, the complexity. It's not really complex. It's just, time consuming. And remember, this is equal to 12. All right, awesome. So now, if you simplify this, again, I'll spare you the trouble, you're going to get the following quintic. S to the 5th power minus 25s cubed plus 45s squared plus 27 equals 0. And again, for solving this, obviously, if you wanted to use the rational root theorem, you would use the divisors of 27, 1, 3, 9, 27, plus minus, so on and so forth. But s equals 3 happens to satisfy, and I checked it for you. It satisfies this equation. If you plug in s equals 3 here and here, 3 cubed is going to be 27 plus 18 is 45 minus 45 is going to be 0. Yay! P becomes 0 from here, which is real nice because that gives you a lot of good information. Remember, P is the product, so P equals 0 means xyz is equal to 0. So we're going to alternate, but let's just go ahead and assume that z is equal to 0, or find out what happens if z is equal to 0. Now, if z is equal to 0, obviously, from the sums and the products, we get x plus y equals 3, and the sum of squares gives us x squared plus y squared is equal to 5. Obviously, product is not going to help because we know that it's 0. But this is a quadratic system. It can be solved very easily. If you just square x plus y, you get x squared plus y squared plus 2xy. And I know that this is 9 and this is 5. Therefore, xy becomes 2. So let's go ahead and add that to our system. Now I have x plus y equals 3 and xy equals 2. Obviously, solving that system even mentally would be super easy. That means x equals 2, y equals 1, or vice versa. So from here, we basically get 2, 1, and for x, y, we get 2, 1, or 1, 2. But we know that xyz is equal to 0, and our assumption was that z is equal to 0 in this case. So obviously 2, 1, 0 and 1, 2, 0 will be possible solutions, but they're not all of them. Also, the permutations of all of these will be solutions. So to sum it up, the solutions can be written like this, and in set notation, so we don't have to worry about the permutations. The set xyz is equivalent to the set 0, 1, 2, which means xyz can take all of these values in different orders. And this brings us to the end of this video. Well, thank you for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you tomorrow with another video. Sorry about the lengthy video because this is a crazy system. But anyways, I'll see you tomorrow. Until then, be safe, take care, and bye-bye.